Hello everyone, class 12th. Topic is oxymercuration reduction of alkene to prepare alcohol. Yesterday we have done hydroboration oxidation of alkene to prepare alcohol. Now we have this. Let's check what the reaction is. Any alkene you can use, symmetrical or unsymmetrical. I am using unsymmetrical. Prop 1 in. For this reaction, the reagent required is this one, mercuric acetate. This part you can check, it is acetate part. Now between mercury and oxygen covalent bonds are available. Oxygen is more electronegative than mercury. Electrons are going toward oxygen side. Now mercury is losing two of its electron, that's why it is carrying partial +2 charge. Due to this positive charge, it have a ability to attack on electrons. That's why it is working as electrophile. Who can provide electrons to it? Alkene. Alkene have a pi electrons. Pi electrons are always easy target for electrophile. These pi electrons are available between these two carbons. Mercury will prefer to attack on this carbon. Reason, Markovnikov rule, because after attacking this carbon, when pi electrons will shift toward this carbon, 2 degree carbocation will generate, which is better as compared to 1 degree carbocation. If mercury attack this carbon, pi electrons will shift this side and carbocation generated will be 1 degree. So reaction always prefer 2 degree carbocations over 1 degree because 2 degree carbocations are more stable as compared to 1 degree. Now mercury can make two bonds. Obviously one old bond will break. Suppose this bond is breaking. When bond will break, both electrons obviously will go toward oxygen because oxygen is more electronegative than mercury. Next condition will be this. This part will release out as oxygen already carrying a 2 lone pair. After breaking bond from mercury, it will get third. In this third pair, one electron is of mercury, that's why oxygen is carrying extra negative charge, -1, acetate ion. And watch here, what is happening? Bond formation and bond breakage is present in this transition state, which we call pi complex. Like in hydroboration oxidation reaction, we got transition state. Here also we have a transition state in which actual means perfect carbocation or open carbocation is not generated. Only a partial carbocation is generated, whose degree is 2. Mercury is making bond with carbon like this, due to which pi electrons are started to move toward this carbon. So due to which when electrons will move toward this carbon will get a positive charge, partial positive charge, because the pi electrons are not completely transferred right now. They are just little bit moved toward this carbon because of effect of mercury. Mercury was coming to this carbon for bond formation, due to which bond formation is started, and from here bond breakage is started. Such complex is known as pi complex. Now this is the carbocation which is generated. Obviously it will be attacked by a negative particle. This whole reaction is happening in THF and water, tetrahydrofuran and water, working as a solvent. Now there are two particles which can satisfy this carbocation. It's a positive particle, need electron. There are two particles who can provide electrons to it. One is acetate and one is water molecule. Because in water molecule, oxygen also have a lone pairs which it can donate to this carbon, and in acetate, this oxygen also have a 3 lone pair which it can donate to this carbon. Now out of acetate and water, which will attack on this carbocation? The answer is water. Reason? You can check. This is a bigger particle, bulky group already attached on this carbon. This bulky group is creating steric hindrance over here. Steric hindrance, due to steric hindrance, this bigger particle will feel difficult to attack on this carbocation. Already very much crowding is there. In that crowding, the bigger particle will not get fit easily. That's why the small particle, this will attack on carbocation. Due to this particle, crowding is generated over here. In this crowded condition, this bigger particle can't attack on the carbocation. It will also feel repulsion. That's why which particle is used? Water molecule, which is smaller as compared to acetate ion. So oxygen is going to provide electrons to this carbon. Again, I am drawing that condition. This is the condition in which water molecules are going to attack on this carbocation. Now, when water molecules will attack on this carbocation, complete transfer of pi electrons will happen toward carbon, which that carbon will use to make bond with mercury. So, after this attack, this oxygen with lone pair will make bond with this carbon, and around this oxygen 3 bonds will generate. And here now you can check, I am not drawing any dotted line because dotted lines means pi electrons are completely transferred toward this carbon, and which this carbon is using to make bond with mercury, like this. Now in this condition, oxygen will carry +1 charge. Reason? Because for bond formation 2 electrons are required. This carbon don't have electron for bond formation. Oxygen is providing both electrons for the bond formation. Out of these 2 electrons, 1 electron it is keeping with itself, and 1 electron it is transferring toward carbon, due to which it is carrying +1 charge. In this condition, oxygen is unstable. What it will do? It will break bond from hydrogen. And obviously oxygen is more electronegative than hydrogen. It will shift electrons toward itself. Oxygen will carry now 2 lone pairs, HgO, CO, CH3 as it is. And what will release out from here? H positive particle will release out. This hydrogen will release out as a H positive. Now check this compound. This is known as oxymercuration product. Oxymercuration means add of oxygen and mercury. You can check, on this carbon mercury is added and on this carbon oxygen is added. So which processes happened there? Oxymercuration process. Now wait, is it a final product? No. Because what was the name of the process? Oxymercuration-reduction. So out of oxymercuration and reduction, oxymercuration is happened. We got oxymercurated product. Now it's a time of reduction. For reduction, we are using a reducing agent, that is sodium boron hydride, NaBH4. In NaBH4, Na is carrying +1 charge and boron hydride is in this condition. Boron is carrying -1 charge. These 3 bonds are covalent, and this 4th bond is a dative bond which is made through hydrogen. Hydrogen has given lone pair to boron in its, like this. It was BH3. It had, This is hydride. Hydride donated its lone pair in the vacant orbital of boron, and that's why we got BH4. Now, right now boron was neutral. After gaining one electron, you can check in this bond, one electron hydrogen will keep and one electron it will transfer toward boron. So boron is getting -1 charge. This is the condition of sodium boron hydride. Now, in that reaction, what it will do? The bond between hydrogen and boron will break. Hydrogen is more electronegative than boron. Both electrons will go toward hydrogen and BH4 negative will turns to BH3 and hydride particle will generated back. Now this is a negative particle. We'll try to attack on positive particle. Do we have a positive particle? Yes. In oxymercuration product, this was oxymercurated product where we have positive particle. This carbon is a positive particle over here. Reason: this carbon is connected to mercury, but mercury is connected to two highly electronegative atoms, oxygen atoms. That's why this whole group is working as strong electron attracting group. Due to very high electronegativity of these oxygen, strong -I effect is generated. This whole group is attracting electron from carbon side. That's why carbon is carrying very high positive charge. Due to this high positive charge, this hydrogen will start attacking on it like this. And when hydrogen will make bond with this carbon, these two electrons which were present in this bond will go toward mercury side and bond will break like this. And finally, what we will get, here I am writing CH3 CHOH, and here two hydrogens were there with this carbon. Now we will have three hydrogens, and this mercury will release out as Hg carrying a lone pair OCO CH3, this one. Please check this product. What it is? Alcohol. What kind of alcohol? 2-degree alcohol it is. That's it. This is the end of the mechanism, oxymercuration and reduction process. Oxymercuration reduction, we can call this reaction, or we can also call it oxymercuration demercuration also, because you can check oxymercurated product has lost mercury 1. So we can call it demercuration also. That's it. This is the end of the mechanism. With this process, you can get 2-degree alcohols. Thank you very much for watching the video.